So in this lecture, I would like to talk about Einstein's approach to explain photoelectric effect. So Einstein used the idea of quantization of energy. So idea which was used by Einstein is the quantization of energy. As suggested by Max Planck, in the explanation of blackbody radiation. And using this idea, this is a revolutionary idea. So Einstein used it, and what Einstein assumed that light is coming in the form of packet of energy, Before Einstein, the wave nature of light is dominating, but here Einstein assumed that light is coming in the form of energy, and he called it as quanta or photon. This packet of energy is known as quanta or photon. And the energy of this packet is proportional to frequency, or in other words, we can say that E is equal to h nu, where h is the Planck's constant. Its value is 6.62 into 10 raised to power minus 34 joule second. So Einstein proposed that when photon fall on the metal surface, means it's a packet of energy, when it fall on the metal surface, so whole of the energy is transferred to the electron. And say if h nu is the energy of the incident photon, it is equal to work function plus half mb square. It is the maximum kinetic energy of the electron. So what is it? This is the energy of incident photon and what is it? This W naught, let us call it as work function of the metal and this is basically the maximum kinetic energy of the ejected electron, maximum kinetic energy of the ejected electron, and let us define work function. Work function is nothing but it is the minimum amount of energy required to just knock out the electron. So first advantage of this theory is that as Einstein assumed that this incoming photon directly interact with the electron, and if its energy is large enough, then it will knock out the electron instantaneously. So the main problem with the classical theory that it was not able to explain the explain the instantaneous emission of electron, but the assumption of Einstein's theory automatically explained the instantaneous emission of electron, right? So that is the advantage of this theory. Main advantage. Then if we try to look at the equation again, that this equation can be written as h nu is equal to, if I replace work function with the h nu naught, and this is half b square, and this is maximum kinetic energy. So I can express this as simply Ke. So kinetic energy of the electron is nothing but h nu naught and h nu minus h nu naught. This equation can be rewritten in this form. And if I try to plot it, because this is looks like a straight line equation, it's the equation of line. So if we try to plot it, so it is nu naught, it is nu axis, and it is kinetic energy, or we call it as EV naught. Kinetic energy can be replaced with the EV naught. So it automatically explain the this that if frequency of the photon is less than some certain frequency, we call that as the threshold frequency, then no electron will be ejected. And if we further beyond that, if we increase the kinetic energy, or sorry, if we further increase the frequency of the incoming photon, then kinetic energy or the maximum kinetic energy increases linearly. And this can also be explained now. And another third or another thing, that photoelectron or the photocurrent increases linearly with the intensity, because intensity increases as the number of photons will be increases. And but this will happen if the photon frequency is larger than certain frequency, and that certain frequency is known as threshold frequency, right? So nu naught is known as threshold frequency, right? So that means this Einstein's theory completely explained the photoelectric effect, and for this Einstein got Nobel Prize in 1921. Nobel Prize in 1921. So for his services to theoretical physics and especially for the explanation of photoelectric effect. But he got Nobel Prize in 1921, but received in 1922, right? So with this, there is end of second part, that is photoelectric effect. And in the third part, I would like to explain the spectrum of hydrogen atom and how it can be explained by Bohr.